In this video, I would like to look at numbers in mathematics. Numbers in mathematics are very important. When you solve equations, we are basically looking for numbers. And there are three ways where numbers are characterized in mathematics. And that's by name, by symbol, or by mathematical definition. These are the ones I'll try to present to you in this video. I also want to show you that numbers form a clear hierarchy. You will see in a moment what that is. But the way we'll do this is I will introduce each set of numbers, and then we'll go from there. The very first set of numbers in mathematics are called natural numbers. Sometimes these are called the counting numbers. The set of natural numbers include 0, 1, 2, 3, 4, and so on. These are essentially whole numbers, positive whole numbers, including 0. Please be aware that in some textbooks you might see other definitions where 0 is not included here. That is perfectly acceptable because there is no agreement in the math community of which of the definitions is correct or is accepted. Next, we have integers. Integers are the extension of natural numbers. So integers are the set of numbers that include negative whole numbers as well as positive whole numbers with 0 included. One thing you should take away from integers and natural numbers is that they do not accept fractions or decimals. Okay, so that's a defining feature of these sets of numbers. Next, we have rational numbers. So rational numbers are the set of numbers that you can write as a fraction. In this case here, the definition says rational numbers are the numbers you can write in the form a over b, where a here is the numerator and b is the denominator. And a and b are integers, and b cannot be 0 because we do not want to divide by 0. I have some examples here: 1/2 minus 3/4 and 0.25. Clearly 1/2 is in this form, 1/2, because 1 and 2 are integers. Minus 3/4 is the same because minus 3 and 4 or 3 and minus 4 are integers. What is not immediately obvious is 0.25, but looking down here, we can write 0.25. We can convert it from a decimal to a fraction, 25 over 100, and then now we can simplify it to 1/4. And indeed 1/4 is a fraction because 1 and 4 are integers. Okay, so real numbers. The next one are called real numbers. Real numbers are all the points on the number line. I would say real numbers are probably the ones you've heard before. But what is interesting about real numbers is that they also include other numbers called irrational numbers. These are numbers that you cannot represent as a fraction. In fact, they are the exact opposite of rational numbers that we've just seen. These include numbers like √2 or pi or e. Now you can see √2 here. I wrote √2 with a few decimal places and then dot 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 at the end. This indicates that √2 goes on forever. It is a recurring decimal. It doesn't stop. The same with pi and e. Um, so the reason why we were able to, for example, we can convert 3.5 into a rational number or to a fraction is because this is called a non-recurring decimal. It doesn't repeat endlessly. This is not the case for these numbers. Okay. And then lastly, we have what we call complex numbers. Complex numbers are numbers that you can write in the form a plus bi, where in this case a and b have to be real numbers, the ones we've just seen. And then I is defined as the square root of minus 1. Real numbers are usually given the simple symbol z. Um, you often hear people saying, "Oh, complex number z equals a plus bi." Um, but what you need to take away is that there's a real part and an imaginary part. So the a is usually called the real part, and b is called the imaginary part. I have three examples down here, but let's focus on 2 plus 3i, the very first one. If z equals 2 plus 3i, and then we can extract a few things. That is, the real part of z is equal to 2. Okay, this number right here, that's the real part of z. And then the imaginary part of z is equal to 3. Okay. Okay, so this is what we've done so far. This is a summary of the numbers in mathematics. Um, the very first one, natural numbers. The symbol is capital N. The set of integers, the symbol is capital Z. The set of rational numbers, the symbol is capital Q. Real numbers, the symbol is capital R. And complex numbers, the symbol is capital C. These are the ones you need to know, especially if you will be taking college classes or university level courses. Because trust me, you will see this in one form or another. And I've seen that students get intimidated by taking math courses simply because they're not familiar with the definition or with the notation. Once you are familiar with this stuff here, you'll be positioned really well to take advanced courses in college. Okay, so don't try to memorize, just be aware of these symbols and the definition, the mathematical definitions. You can see the set of numbers. You can see natural numbers. These are all the positive whole numbers including 0. Integers, these are all the whole these are all the whole numbers including negative numbers and positive numbers and 0. Rational, these are the set of numbers you can write as a fraction. Or these are all the numbers on all the points on the number line. And then complex numbers is basically on the number line you introduce another dimension. For example, the y-axis. We call so this a here, the real part, it represents the number line on the x-axis, and then the b high here is the y-axis. Okay, so that's the imaginary axis. And yeah, so that's it about numbers. Right now, I would like to take this opportunity to show you that these numbers actually do form a hierarchy, and here's why: by putting them into boxes. The very first box is the box of n, the natural numbers. The next one is z, and the next one is q, r, and c. Now, one thing you'll see, for example, let's focus on Z. If you look at Z here, inside of Z there's another box, N. So if N is inside of Z, this tells you that all natural numbers are actually integers. Or if you look at Q, inside Q we have N and Z. This tells you that N and Z are actually a subset of Q, which means that all integers are actually rational numbers. The same with R. And so this tells you that Q, or all rational numbers, are actually real numbers. All integers are real numbers. All natural numbers are real numbers. And then C. C is the biggest box of all. So this tells you that R, the set of real numbers, are actually complex numbers. The same with Q, Z, and N. This is where the hierarchy is coming from. Okay. Now, I would like to go through a few examples. And the goal is to classify these examples into the set of numbers we've seen so far. I have 0, -3, 1.5, 1 plus root 2, and 2 plus 3i. We start with 0. Where does 0 belong? So clearly, 0 belongs to all the set. Belong to N, belong to Z, Q, R, and C. Oh, and notice how you can write 0 as a complex number. 0 equals 0 plus 0i. Here the real part is 0, the imaginary part is 0. This tells you how you can write any number as a complex number. Okay? -3. Clearly, -3, the only set of numbers that it does not belong to is N. Remember, N are the set of whole positive numbers. Otherwise, -3 is an integer, a rational number, a real number, and a complex number. And notice how you can write it as a complex number here. 1.5. So 1.5 doesn't belong to Z or N, because these two only accepts whole numbers, not fractions or decimals. Okay. Otherwise, it belongs to Q, to R, and C. And notice how I can convert a 1.5 from a decimal to a fraction. You write it as 15/10, and then you simplify it to become 3/2. And indeed, this is a rational number. 1 plus root 2. In fact, this one is a radical. You cannot simplify it any further. The only other way you can write it is to write it as a decimal. But since we've seen root 2, it's a recurring decimal. It goes on forever. So there's no simple decimal representation of this number right here. In fact, this is an irrational number, and it belongs to R and C only. 2 plus 3i, these only belong to C. Okay. If we put them into a table, we can see how how they, which boxes they check so far. And you can see 0 will check every single box, because 0 is a natural number, 0 is an integer, 0 is a rational number, 0 is a real number, and 0 is a complex number. And notice -3. So -3 doesn't check N, because -3 is not a natural number because it's negative. But otherwise, it checks the rest of the boxes. The same goes for 1.5. You can see it doesn't check the first two, but checks the remaining boxes. 1 plus root 2 only check the last two boxes. So, which means this is a real number and a complex number. And then, of course, the last one only check the last box. Okay? So that's all you need to know about numbers in mathematics. Don't memorize, just try to understand, and you'll be fine to take advanced courses.